Let me get started on the ground covers. We've done a lot of research on ground covers, so I love covering this. And when I say ground covers, I'm talking about the mulches generally that we're putting on. In the long term, the ground cover is grass usually, but in this section, when I'm saying ground covers, that's what I'm talking about. Matting and mulches, etc. So we know that we have very effective control of erosion when we get vegetation established. And most of the projects are going to use permanent vegetation anywhere that's not paved. So a lot of the areas are going to be covered with grass and sometimes other vegetation. And then we use those ground covers, the mulches, temporarily until the grass gets started, for the most part. So we need to have cover established within a certain amount of time. And it's a little bit different depending on where you are on the project and what kind of project you have. So I mentioned many times that when we're on those edges and where we're running water, so that first line, perimeter dikes, etc., it's a 7-day period of time from the time you're done working it. All right, so that's all these 7 and 14 days. It starts as soon as you're done with the grading operation. And then if you're in a high quality water zone, and that'll be on your plan that you're in a high quality water zone, then it will be noted that you only have 7 days to put some kind of stabilization out on the soil. If we have slopes steeper than 3 to 1, then it's a 7-day period. And that's because these slopes can erode very quickly. They can contribute a lot of sediment. And so we want to make sure we cover them up quickly. Now, if it just so happens it's a slope that's only 10 feet in height, then you can go 14 days. Slopes with 3 to 1 slopes or flatter, you've got 2 weeks, unless they're more than 50 feet in length. All right, so in other words, this is sort of a risk analysis. If we've got a long slope, even if it's 3 to 1 or less, it can build up a lot of flow and that can cause a lot of erosion. All right, so then lastly, everything else is 14 days with some of these exceptions. So 7 to 14 days, and as we like to say, sooner the better. So what kind of ground covers do we have as options? Well, straw is the obvious one. We've been using that for a long time. There's erosion control matting. We have hydraulically applied mulch or hydromulch, which many of you may be familiar with. And then we can be using compost as a mulch material as well. So let's go through sort of our cookbook of how we establish vegetation on these projects. So the first thing is to remember that the soil has been severely disturbed. So, you know, when we do a grading operation, we remove the topsoil and we start pushing soil around, and it can get compacted and it's very hard for seed to get established there. So we want to smooth it out and rough it up so that there's a chance that the seed can actually get a root down into the soil. So typically 5 inches or 3 inches on embankments or disturbed areas where things are already kind of loose. You don't want rocks there, roots, stumps, etc. And then you see down below we're tracking the slope. So this means you run a bulldozer with tracks up and down and up and down, and it creates these little check dams as well as these little valleys. And those are great for slowing the flow and holding moisture to help that seed get established. You never want to see tracking going across a slope. All that does is it speeds up flow and creates rills. So it's the last thing you want to do, even though it's a lot faster, I know, to track across a slope, but you want to track up and down. So the soils we're dealing with generally are very low in fertility and they have problems with pH. So we're going to try to fix that. So we're going to add some lime and we're going to add fertilizer. So lime is generally used to reduce the acidity of our soil. So most of our North Carolina soils are on the acid side, pH 5, sometimes less. And so we want to add lime to bring the pH up so the grass can grow. Now we want to use generally dolomitic limestone. We're going to use either pelletized or powder. Powder is better if you can stand it. I know it blows and it creates some issues that way, but it dissolves much faster and corrects the pH much faster than pelletized lime. We're going to put out 2 tons or 4,000 pounds per acre. Now, if you were a farmer or even a homeowner, you would take a sample and send it to NCDA and CS, and they would tell you how much lime you needed to grow your whatever you're going to grow. In this case, grass. We don't have time to do that. It takes 3 or 4 weeks and etc. So in order to bring our pH up on most of our soils, we're going to put out this one rate. In this picture, the guy with the lime truck, the spreader had broken, so you can see what he's doing. He's actually throwing the lime out by the shovelful. This is not going to be very successful because he's not getting any kind of distribution of that lime. So the fertilizer is also added because the soil has very little fertility in it to grow plants. And so we're going to put out a nitrogen, phosphorus, potassium combination at 500 pounds of the 10-20-20. So 500 pounds of 10-20-20 means 10% nitrogen, 20% phosphorus, 20% potassium. And every bag of fertilizer should have as you see here, a guaranteed analysis, which will tell you what's in that fertilizer. In this case, you can see there are some micronutrients that happen to be there, but they will list anything that's in that fertilizer that is a plant nutrient. So here's a question for you. How many pounds per acre of fertilizer and lime should be applied? 500 and 4,000, 4,500, 500 and 2,000, or 10-20-20? Well, hopefully everybody got the A, 500 and 4,000. I flipped them for you just to see if you were paying attention. 500 pounds of fertilizer, 4,000 pounds of lime. So we've scarified the soil, kind of tilled it up so the seed can grow. We've added our lime and fertilizer, so we've brought the growth potential of the soil up. Now we need to put out some seed. This can be either permanent or it might be a temporary seed that you're putting out until you come back and do some more grading. We may have native seeds that we have to put out depending on where you are on the project. We want to make sure it's all certified. In North Carolina, we're blessed with a lot of different climates. And in this case, you can see we got a dark green and a light green part of the state. So in the light green, we're generally going to be growing our warm season grasses. This is centipede and Bermuda grass. These grow in the summer, and in the winter, they go dormant. So they turn brown. I always love to tell the story about my uncle who was driving up from the coast, and the first thing he asked me is, why do you all kill your grass in the winter? Well, he was from up north. He'd never seen warm season grass, so I had to explain that to him. So then on the western part of the state, where it's a little cooler, we're going to grow the cool season grasses, and that's fescue and bluegrass. So they stay green year round, grow year round, and they're less tolerant of the hot temperatures we might get towards the coast. So we're going to go through some examples here of how we would choose seed for different projects in different locations and times of year. So here we are, Division 2. That's down east. So it's going to be the warm season grasses. And it's April. We're ready to put out seed. So we're heading into the summer. So we're going to put out a fescue, centipede, Bermuda mix. And the Bermuda you see is hulled. What that means is Bermuda naturally has an outer hard hull that protects it during the winter and slowly degrades and falls off by this time, or April, in the growing season. we don't want that hole to restrict the growth of the Bermuda grass. So they can mechanically remove that hole, and we buy seed that has that done so that it will grow and sprout very quickly. The fescue is sort of a nurse crop. It may stay. It will grow much faster than the other two initially, but we expect the other two to take over. Now, we had a delay in that same project, and we're not finished until December. So now we're heading into the winter, and we're going to use that fescue centipede Bermuda mix, but we're not going to buy hulled Bermuda grass. Instead, we'll keep it native, and that way the hull will protect it over the winter. All right, can we use nurse seed crops for permanent seed mixes? In the East, we do not. We found that those temporary mixes tend to grow too fast and outcompete and hurt the growth of the warm season grasses. So we only use those in the western part of the state. And that's where we are now, Division 10. So we're in the upper Piedmont, and it's March. We're ready to seed our shoulders and medians. So permanent stands, just your normal maintenance type of area. So we'll put out a mixture of hard fescue, Kentucky bluegrass, and now we have a nurse crop, a rye grain, and it's going to grow very quickly, very tall, form some seed heads, and then it'll disappear. So it will protect the site while the other two are getting established. So we're in the same area, however, same project, however, we're now on waste and borrow areas. So these are off the project, and they're on private property. We've gotten permission either to take soil from there or to pile up excess soil on their property. And we want to make sure that area is stabilized because it's off the project, and we won't see it very often. And we want to make sure that the private citizen is happy with the operation. So we'll be putting a lot of fescue. You can see the tall fescue, as well as the hard fescue and bluegrass and rye grain. So can we use Kentucky 31 tall fescue? And the answer is no, we don't use it. It has a problem with wildlife. It has an organism in it that can make wildlife sick. So we don't use Kentucky 31, but there's lots and lots of other tall fescues that we can use. So there are areas usually around waterways and wetlands where we're going to go back with native grass seeding. So in that case, 50 feet on both sides, we'll get this material. We're looking at Bermuda mix in the eastern part. So you can see you've got Indian grass, blue stem, switchgrass, and brown top millet. So we're putting that out. Eventually the Bermuda grass hopefully will die out and we'll have all the native grass take over. And then in the western part of the state, we're using a Kentucky bluegrass mix with blue stem, Indian grass, switchgrass, and the rye grain. So native grass seeds are notoriously expensive, so we don't use that on a lot of the areas, just near waterways where wildlife might occur. So what are some of the most common problems we have with seeding? Well, first, inadequate cover. We didn't put enough material out on top of the seed to protect it. We'll get to those covers in just a minute. Poor seedbed preparation. So we didn't scarify it. We've got compacted soils. We didn't track it. This is a site on the right where they tried to seed it, and you can see they didn't do any of that. Not enough amendments. Didn't get enough lime and fertilizer out to correct the soil fertility and pH issues. Or we're using old seed. So we should always be using the current seed from the last season. So we'll see on every seed bag, there'll be a tag and it'll tell you what year it was harvested and what's in the seed, how much weed seed, etc. But the main thing is the time. So we don't want to use 3-year-old seed because seed is a living organism and it's probably died out and you may get only 10% germination. So about those ground covers, we're back to that. We got the straw, we've got erosion control mats, we might have permanent reinforced mats, as you see in the lower right. Why do we use straw? Well, it's actually a good ground cover and it's inexpensive compared to the others. So that's going to be our go-to for the most part. So we're going to put out 1 or 2 tons, but the amount is not so important as the coverage. So if you have a wet bale, it's going to weigh a lot more than a dry bale. So you don't want to go by weight, you want to go by coverage. And we want to see 85 to 95% of the soil covered up. We're going to use it on 2-to-1 slopes or less. So we don't want to use it on steeper slopes because it'll wash off. It's very good at holding moisture and shading the seed. Still allows air circulation so you don't get disease. But you can't have bare spots and you can't have clumps. The thing about straw is it's very easily blown away by wind. So we tackify it, and we want to just put enough to hold it in place. So lower left, this is the emulsified asphalt that we've been using for many years, hopefully getting away from. That's way too much tackifying. Once you put too much on, you can actually stunt the grass or kill it. So it's a difficult operation. You have to have a heated tank, and I think everybody that's ever done it ends up with a lot of asphalt on them. So this is an example. This is actually an experimental plot we had where they put out a bunch of tackifier, the asphalt, and you can see it killed the grass. They put way too much right in this spot. And you can look around, the rest of it looks good, but where they over applied, they killed the grass. So the other option that we've worked on and that we suggest is a good operation or a good alternative is using the Hydromulch. So you can see here on the lower right part of this picture, that's straw that's been put out, and they're putting out just enough Hydromulch, in this case 1,000 pounds per acre, which is about 1/3 of what they would normally put out for erosion control. And this will hold the straw in place just as well as the asphalt. So we also have matting. Most of the time we're going to use for DOT projects Excelsior matting, which is in the upper right of your picture. I think you can sort of make out here the fibers. So they shave these fibers off the aspen logs and form them into blankets that are good in a lot of ways because they don't have any weed seeds. So lower right, these are straw blankets and they can carry weed seeds. So we want to make sure we trench in the upper end so water can't get underneath the blanket. We put a lot of staples in so that it holds it in place, but also keeps it flat on the ground, doesn't allow tenting or the blanket not being in contact. So here are some diagrams of those blankets being put out. So you see we got some specifications here. You want to have 4-inch overlap, staple through both of those blankets so there's no way water or wind can get underneath there. In this case, they're showing these stapled check dams, which apparently some people do use. One of the most important parts of this diagram, though, is here. So we need to anchor that top edge. So at the top, we're going to dig a trench. We're going to put that blanket in and staple it. Then we're going to fill it back in and then roll the blanket across it. That way, there's no way water can get underneath this, this blanket. So this is another way to look at it. It's sort of counterintuitive. We do this in the field all the time. We give people a roll and ask them to trench it in. They almost always trench it in backwards. So what I mean is, what you need to do is get the roll so that the flap is coming off the top. All right, then we get enough fabric off the top to stick it in that trench, staple it in, fill in the trench, and now since we took it off the top, we can just roll it across and down the hill. Excuse me. So the most common mistake is people take it off the bottom, and you can kind of picture if you took it off the bottom, how am I going to roll it? Because it's going the wrong way. So make sure you take the flap off the top. If we're putting blankets in a ditch, then some of the same principles apply. We want to make sure there's lots of overlap and a lot of staples to keep it in contact with the soil. Flowing water, if it gets underneath a blanket, will cause a big blowout. So you don't want to have any gaps there. Also note that when you're done with a roll at the end goes on top of the next roll. So just like tiling it or like a roof shingle. You want to have the upper end on the top of the lower start of the new roll. Lots of different materials out there for erosion control blankets, and lots of different nettings that are used for them as well. So generally we're using the plastic netting. Be a little bit careful about that. It may be, especially this type of plastic netting, it's really good at trapping wildlife. So we can also use these, what are called permanent soil reinforcement mats or turf reinforced mats. These are used instead of riprap in a ditch that's going to carry water. So picture that we're putting down this permanent matting. So this is all plastic material, so it's there forever. The grass is going to grow up through it, and in this case we got some coconut fiber that will eventually go away, but we're going to be left with some plastic matting. And these channels can handle just the same kind of flow as a rock line ditch, and some say they're more aesthetically pleasing. But the grass grows up through it, and as a result you get kind of a redoubling of the strength of that material. We want to make sure that the blankets never get undermined. That's why we were talking about getting the top keyed into the soil. So here's a case where very expensive turf reinforced matting put on this bank, and the water got underneath it because they didn't trench it in. And now we've got, you can't see it, but there's a big gully right there. Want to make sure there's enough staples so that you keep it in contact with the soil. And also you want to make sure, even with blankets, that you don't have water running on them. So here's a case where we had a haul road and water was collecting and then going down the slope. And even though it was a blanket, so theoretically stronger than straw, it can't handle flows like this. So we got gullies. And hopefully all of you are looking at it and saying, well, I wonder why they didn't put in a slope drain there. Well, guess what? They did soon after we pointed this out. So at the top of a slope, blankets should be anchored by stapling every foot, stapling a trench and cover it, 12 inches of soil or Class A rock. Okay, hopefully everybody got B. Staple it in the trench and then cover it up. So hydromulches, we mentioned those as a tackifier. For those of you not familiar, a hydromulch is essentially either a wood or paper or some blend product that has been ground into a fiber material that's put in a tank with water and sprayed out, sort of like paper mache. It's sprayed out as a spray-on blanket. So here you can see that the tank, big truck with a tank here, and he's shooting it out. So on low slopes, you can use a wood fiber material at a lower amount. And then on steeper slopes, I'm calling this fiber reinforced matrix, but there's a lot of different names for these higher end products that have additives, and they've been engineered to handle steeper slopes. So it's very important, though, if people are using hydromulch, that they apply enough and they apply it correctly. So here's a slope that has been hydromulched. I think you can see there's not as good a coverage as you probably want to see. There's still some gaps, etc. Now this has been tracked. So you can see the tracks here. If you go to the bottom and you look up, you can see that because of the tracks, the lower end of every track is not covered. So this is essentially 50% coverage. So what the operator needed to do is get off his truck and bring a hose down to the bottom and shoot half of the material from the bottom and half from the top. So remember that hydromulch always has to be sprayed from both directions. Otherwise, you won't get good coverage. So we want to make sure that once we get to final grade, we get permanent seeding in. There's no reason to wait. Go ahead and get it out as soon as possible. Other areas where we may be grading later on, we would want to put out some temporary seeding. So it doesn't matter. Here's an example. This is all is going to be taken out eventually, but we want to get seeding out, as we talked about, around these ditches. It's temporary, but it's got to be put out. So there is a chance that if your stand is having troubles growing, then you may get some top dressing put out, some added fertilizer. So this is something, it's a special provision that you'd have to talk to the engineer about whether you could do this or not. If you're using fertilizers commercially and you happen to be in the Jordan Lake watershed, then you have to do this training. I don't know if anybody in this class falls into this, but if you're getting paid to put out fertilizer, then you have to do this training if you're in the Jordan Lake area. So this is where you go. You go to this this website, which I show the web address here. And essentially all you have to do is look at some slides and then tell the person, this is Patrick Beggs, that you looked at the slides, and then he sends you a certificate. So pretty straightforward, but it's important because the Jordan Lake is a water supply, and it's got a lot of problems with nutrients. All right, any questions then about the vegetation and all that we just talked about?